Okay, so from this right angle triangle, so you can derive an expression for this. You will get an expression for this cos theta from this right angle triangle itself. So from this right angle triangle, if you consider this particular triangle, what will be cos theta? You know, cos theta is equal to, cos theta is equal to adjacent side by hypotenuse. So as per this right angle triangle, which is the adjacent side? D is the adjacent side. And what is the hypotenuse? Square root of r square plus d square. So adjacent side is D and hypotenuse is square root of r square plus d square. So what will be cos theta? Cos theta is D by square root of r square plus d square. Substitute that expression for cos theta here in this particular formula. So when you substitute the expression for cos theta, you will get the total electric field E is equal to 2 into 1 by 4 pi epsilon naught into Q by r square plus d square into, instead of cos theta, you must substitute the expression for cos theta. What is that? D by square root of r square plus d square. Okay. Now next, equal to 2 into 1 by 4 pi epsilon naught into QD by Q into D. Q into D is QD. And next, here we have r square plus d square. Here we have square root of r square plus d square. And you know, square root of r square plus d square means what? Square root of r square plus d square is nothing but r square plus d square whole raised to 1 by 2. Okay. So when you multiply two similar terms with different powers, use the properties of power. What is that? Just add the power. So here you have r square plus d square and its power is 1, and you have r square plus d square all raised to 1 by 2. So when you add the power, you will get 1 plus half. 1 plus half is 3 by 2. So what will be the expression? 2 into 1 by 4 pi epsilon naught into QD by r square plus d square all raised to 3 by 2. Okay. Now, next, just rearrange this expression. So whenever you rearrange the expression, you will get E equal to 1 by 4 pi epsilon naught into, take this Q here. Okay, write 2 along with the QD. So you will get 1 by 4 pi epsilon naught into 2 QD by r square plus d square all raised to 3 by 2. Then what is 2 QD? 2 QD is nothing but expression for dipole moment P. So instead of 2 QD, write P here and you will get 1 by 4 pi epsilon naught P by r square plus d square all raised to 3 by 2. Again, here also we can take the same assumption as we did for the axial position. If distance r is very much greater than d, we can neglect the term d. So here also we can neglect the term d square. So what you will get? You will get A equal to 1 by 4 pi epsilon naught into P by r square all raised to 3 by 2. And here also you can use the properties of the powers, that is r square all raised to 3 by 2. So how will you simplify this? 2 into 3 by 2. 2 into 3 by 2 means 2 cancel, and what is left? R cube. So r square all raised to 3 by 2 is equal to r cube. So we will get equal to 1 by 4 pi epsilon naught into P by r cube. And this will be the expression for electric field intensity at a point lying on the equatorial position of a dipole. And what will be the direction of this electric field? So in order to get an idea about the direction of electric field, just come back to the previous slide. Here we have the figure. So what is the direction of resultant electric field? At the point P, this is the direction of resultant electric field, right? And here, this is minus Q charge, this is plus Q charge. And what will be the direction of dipole moment? You know, dipole moment always acts from minus Q to plus Q charge. So this is the direction of the dipole moment P. And this is the direction of the total electric field intensity. So how are they related? Yes, the total electric field intensity at the point P is opposite to the dipole moment. Okay, so the electric field intensity on the equatorial position is opposite to the dipole moment. But what was the case in the the direction of electric field intensity when the point P was in the axial position? Yes, the electric field intensity acts along the same direction of the dipole moment. But in the case of equatorial position, the electric field intensity acts opposite to the dipole moment. Okay, so we can write in vector form, we can write electric field intensity equal to 1 by 4 pi epsilon naught into P by R cube into minus P cap, where minus P cap indicates the direction of dipole, indicates the direction of electric field. The negative sign shows that the electric field intensity is opposite to the dipole moment. Okay. Now we can just have a comparison between the electric field intensity due to dipole at a point on axial position and equatorial position. And here we have the expression for axial position, that is electric field intensity on the axial position, that is E equal to 1 by 4 pi epsilon naught into 2p by r cube into p cap. Here the electric field acts along the dipole moment P. And here we have the electric field intensity at a point on the equatorial position, and this electric field intensity acts opposite to the dipole moment P. Okay. Next, which will be a stronger field? Whether the field acting on the axial position or the field acting on the equatorial position. That will be the next point of discussion. So what do you think? Which will be stronger? Let's explain this point through a figure. So here you consider a dipole minus q and plus q, and on the axial position we have a point P, and this point is at a distance of r from the center of the dipole. Now consider another point Q. This point is also situated at the same distance r from the center of dipole, but what is the difference? This point is on the equatorial position of the dipole. So if point P is at a distance of 10 centimeter from the center of dipole, this point Q is also at a distance of 10 centimeter from the dipole. So the distance from the center of dipole is same, but one is at the axial position, that means P is at the axial position and the point Q is at the equatorial position of the dipole. So this Q will experience an electric field and this P will also experience an electric field intensity. So which electric field intensity will be stronger? Electric field intensity experienced at the point P or electric field intensity experienced at the point Q? It is the electric field intensity experienced at the point P. Why? Because here what will be the electric field intensity? 1 by 4 pi epsilon naught into 2p by r cube. Right? Because this is the expression for electric field intensity at the axial position. And at the point Q, what will be the expression for electric field intensity? It is 1 by 4 pi epsilon naught just p by r cube. This is the expression for electric field intensity on the equatorial position. Okay, so on the axial position, the electric field intensity is twice than that at the equatorial position. Or we can also say like this: the electric field intensity on the equatorial position depletes faster. Depletes means decreases faster than the electric field intensity on the axial position. So why is it so? Because from the two expressions it's very clear, as the distance from the dipole increases, electric field intensity decreases, right? Because the distance r is in the denominator in both the expressions. So as the distance of point P or point Q from the center of dipole increases, the electric field intensity experienced at these points also decreases. But which point experiences a depletion in electric field faster? At which point experiences a faster depletion of electric field? Which will be that point? Q. Why? Because its electric field intensity is less, or it's less strong as compared with the electric field intensity at the point P. Okay, so the electric field intensity experiences a stronger depletion for a point lying on the equatorial position. With this, I am concluding my session. Notes of the topic and a YouTube video have been uploaded. So please go through that. Attend the test seriously and post me the answers quickly before 3 p.m. We will meet in the next session. Till then, take care. Stay home, stay safe, keep learning. Thank you.